All right, so for today's deep dive, we're going to unpack something pretty fundamental. We're looking at a spectrum of knowledge.
Yeah, a line that basically runs from the simplest possible truth you can imagine all the way to a kind of engineered computational chaos.
And the simple truth is just a single binary bit. And the chaos, a SHA-256 cryptographic hash.
And I think what's so fascinating here is that the spectrum isn't really about knowing versus not knowing. It's about the cost of knowing anything.
The cost, what do you mean?
Well, you go from a state where truth is immediate, it's basically free, you just see it, to a state where the truth technically exists, but it's buried under this insane computational barrier.
A barrier so high, it's like physically impossible to overcome.
Exactly. So let's start at that first pull. Absolute certainty, the binary system.
Right. Think of a light switch. It's either on or off. If you know it's on, you know with 100% certainty that it is not off.
And that works because of these two fundamental rules of logic, right?
Mm-hmm.
The law of non-contradiction and the law of the excluded middle.
No contradictions, no middle ground.
Mm-hmm. And that creates what game theory calls a state of perfect information.
Like chess.
Precisely like chess. Every piece is on the board. You see all the variables. There are no hidden cards.
And from an information theory perspective, what does that mean?
It means there's zero surprise left. A coin flip, before you see it, has one bit of uncertainty. The second you look, that uncertainty, that surprise just collapses to zero. You know everything there is to know.
Okay, so that's one end. Simple, perfect, known. But then we get to the other end of the spectrum, SHA 256.
Right.
Now, wait. Before we call it chaos, the algorithm is deterministic, isn't it? The same input always gives you the same output.
It does. And that is the absolute core of the paradox. It's the deterministic paradox.
So how can something be certain and chaotic at the same time?
Because it's designed to be functionally unknowable for anyone trying to go backwards. The path from the output, that long string of numbers back to the original input, it's mathematically impossible to trace.
So how does the math actually achieve that? What's the trick?
The engine behind it is something called the avalanche effect.
Okay.
You change just one single bit in the input.
Yeah.
I mean, capitalize one letter in a sentence.
Yeah.
And on average, half of the 256 bits in the output will completely flip. It creates this massive, unpredictable cascade.
Wow. So it just obliterates any statistical connection between what went in and what came out.
Completely. Which means your only option to reverse it is to just guess, brute force it.
And the number of guesses you'd have to make is that 256 number, right?
Yeah.
Which is, what is that in real terms?
It's a number that's hard to even describe. It's around $1.15 times 1070.
Yeah.
It's vastly more possibilities than there are atoms in the entire known universe.
So it's not happening.
It is not happening. And that's why we call it computational security. You could theoretically break it if you had an impossible amount of energy and time.
But that's different from that thing called a one-time pad, right? I remember reading that's a higher level of security.
A much higher level, yeah.
Yeah.
A one-time pad has what we call information theoretic security. That means it's mathematically impossible to crack, even with infinite power. SHA-256 is just practically impossible.
Okay, so let's tie this all together. This spectrum we've been talking about, it seems like it's mapping the decline of our own agency from a world of logic we can handle to a world of complexity where all we can do is guess.
I think that's a perfect way to put it. It maps the energy cost of knowledge. The more complex things get, the more energy it costs to know the truth, until the cost becomes infinite for us.
So what's the final thought we should leave people with?
Well, if you want to connect this to something bigger, think about this. If the universe is deterministic, governed by classical laws of physics,
Okay.
then you could say the future is just a hash of the present. And our inability to predict it isn't because it's random. It's because of that same avalanche effect of complexity. The future is deterministic, but for us, it's completely unknowable.
So the math of the hash literally defines the edge of what we can ever know.
It defines the horizon of our ignorance.